For more than 70 years, we thought our map of the solar system was complete. A familiar and tidy collection of 9 worlds orbiting a single star. But far out in the frozen darkness, billions of kilometers from the furthest known planet, a ghost was lurking. A tiny point of light, slowly, almost imperceptibly, drifting across astronomers' forgotten photographs, unnoticed and unknown for years. Its discovery wouldn't just add a 10th name to the roster of planets orbiting our Sun, it would trigger an identity crisis for the solar system itself, forcing astronomers into a bitter conflict over the meaning of one of the most fundamental words, and, in the process, redrawing our map of the solar system forever. This is the story of the world that, true to its name, sowed discord in the scientific community. I'm Alex McColgan and you're watching Astrum. Join me today as we travel to the chaotic outer edges of our solar system to meet Eris, the world that started a war over the meaning of a single word: planet. The story of Eris begins not with a lucky glance through a telescope, but with a monumental effort to take an inventory of the Sun's most distant subjects. At the Palomar Observatory in California, a team of astronomers, Mike Brown, Chad Trujillo, and David Rabinovitz, had embarked on a systematic survey of the outer reaches of our solar system, looking for signs of objects orbiting beyond Neptune, dubbed trans-Neptunian objects or TNOs. The team were using the 1.2 meter Samuel Oschin telescope to capture images of a wide field of the sky, putting them through automated image searching software that flagged objects moving at a certain speed, and their search had already proved fruitful. With newly discovered worlds like Quawa, Orcus, and Sedna, they were gradually populating this dark, distant realm. But the team were hoping to find something bigger. As Mike Brown later wrote, there had to be a 10th planet. The possibility that Pluto was a unique planetary oddball out at the edge of the solar system seemed absurd to me. He decided to manually re-examine some old datasets that his software had passed over. Then, after months of rechecking, on the 5th of January 2005, Brown began clicking through a sequence of 3 images from the 21st of October 2003, and there in the images was a single, faint dot of light, moving at a glacial pace against the background of fixed stars. Brown knew instantly that this was something significant. It was bright, meaning it was either large or highly reflective, and it was moving far slower than anything they had found before, meaning it was incredibly far away. His first thought was, "I found a planet." The team began tracking the object, provisionally designated 2003 UB313, to determine its orbit and size. They had planned to keep their discovery under wraps until they had completed further observations, but the competitive world of planetary science intervened. On the 27th of July 2005, a different team controversially announced the discovery of another large TNO, Haumea, after accessing Brown's team's public observation logs. To avoid being scooped again, Brown's team was forced to go public. On the 29th of July, they announced the discovery of not just one, but 2 major bodies in the outer solar system, Haumea and this new object that would eventually become known as Eris. The secret was out, and the solar system would never be the same. In Greek mythology, Eris is the goddess of strife, a malevolent deity who, when snubbed from a wedding, tossed a golden apple inscribed "For the fairest" among the goddesses, instigating a quarrel that led directly to the Trojan War. In 2005, the discovery of the celestial body that would bear her name was the modern equivalent of that golden apple, thrown into the halls of astronomy. It ignited a scientific war over the very definition of a planet. The problem was simple, yet profound. Initial estimates suggested Eris was larger than Pluto, and subsequent calculations based on its moon's orbit showed it was 27% more massive. If Pluto was a planet, then Eris, its more massive twin, certainly had to be one as well. And if Eris was a planet, what about the other large TNOs that had recently been discovered, such as Makemake, Haumea, and Sedna? Where would the line be drawn? The discovery created an unavoidable logical crisis. As Mike Brown put it, we were either going to have to add new planets or subtract one. The International Astronomical Union, the global body responsible for astronomical nomenclature, was forced to act. At its 26th General Assembly in Prague in August 2006, the question of what is a planet was put to a formal debate and vote for the first time in history. The debate was vigorous and exposed a deep rift within the astronomical community, splitting it into two main camps. On one side were those who advocated for a geophysical definition. They argued that a planet should be defined by its intrinsic properties. If an object is massive enough for its own gravity to overcome its material strength and pull it into a nearly round shape, a state known as hydrostatic equilibrium, it should be called a planet. Under this simple definition, Pluto, Eris, the dwarf planet series, and potentially dozens of other bodies would have become planets. On the other side were those who favored a dynamical definition. They argued that a planet's identity is tied not just to its physical state, but to its gravitational influence on its surroundings. A true planet, they contended, must be the dominant gravitational player in its orbital zone. In the words of the final resolution, it must have cleared the neighborhood around its orbit. The voting process itself was fraught with controversy. The final vote was held on the last day of the 10-day conference, by which time most of the 2,500 attendees had already gone home. Only 424 astronomers were present to cast their ballots, a tiny fraction of the global astronomical community. When the votes were counted, the dynamical definition had won. The IAU passed Resolution 5A, establishing a three-part definition for a planet in the solar system. It must A. be in orbit around the Sun, B. be in hydrostatic equilibrium, and C. have cleared its neighborhood. Pluto, sharing its orbital space with Neptune and a host of other Kuiper Belt objects, failed on the third criterion. A new category was created, the dwarf planet, for objects that meet the first two criteria, but not the third. Crucially, a follow-up resolution was defeated that would have made dwarf planet a subcategory of planet. Instead, the IAU declared that planets and dwarf planets are two distinct classes of objects. In an instant, the solar system was officially reduced to just 8 planets. Critics immediately pointed out flaws in this definition. The phrase "cleared the neighborhood" was ambiguous, and the first criterion, in orbit around the Sun, applied only to our solar system and ignored the thousands of exoplanets that we now know exist. It was not a universal, elegant principle, but a reactive, controversial, and local fix. With the debate settled, at least officially, the Discovery team had the honor of naming their troublemaking world. They chose Eris, a name Mike Brown felt was perfect for the object that had thrown astronomy into such strife. The name was formally accepted in September 2006, cementing the legacy of this distant world as the celestial apple of discord. If Pluto could think, it would no doubt have found itself disappointed at no longer being a planet anymore. But with the change came many winners. For instance, Ceres, formerly considered an asteroid, was able to take its place among the new rank of dwarf planets in 2006. Are you looking for a similar change? Not into a dwarf planet, that might be a bit silly, but into more of a maths person, a problem solver, or are there skills you want to develop? Then you should take a look at Brilliant, the sponsor of today's video. With Brilliant, such transformations are possible. I love how their online courses help you learn visually and interactively, with content designed by MIT, Harvard, Stanford, Caltech, and Google researchers. I've tried their science courses and had a lot of fun with them, and it's actually personalized to you with tailored practice sets and starting difficulty. Anyone can master these skills as long as they're taught the right way. So if you're looking for a New Year's resolution that actually ends in a aha moment, scan the QR code or click the link brilliant.org/astrum in the description to get started on Brilliant for free. You'll even get 20% off an annual premium subscription, giving you unlimited access to all Brilliant has to offer. Having established its role as a cosmic disruptor, it's time to journey to Eris itself and understand the nature of this renegade world. Eris does not reside in the relatively stable, disk-like Kuiper Belt, the home of Pluto and many other icy bodies. Instead, it belongs to a far more chaotic and wild region known as the Scattered Disk. The Scattered Disk is a vast, sparsely populated halo of icy objects with extreme orbits. These are the solar system's outcasts, bodies that likely formed closer to the Sun but were gravitationally scattered into their current paths by Neptune as it migrated into its current orbit billions of years ago. Eris's orbit isn't a circle like you might expect, but a huge ellipse that takes it 557 Earth years to trace. At its closest approach, or perihelion, Eris comes within about 38 astronomical units of the Sun, roughly the same distance as Pluto's average orbit. But at its furthest point, or aphelion, it swings out nearly 98 astronomical units, almost 15 billion kilometers away. That's nearly 3 times Pluto's current distance from the Sun. Eris's orbit is also steeply inclined at 44 degrees to the ecliptic, the plane on which the main planets travel. This means Eris spends its 557 Earth-year-long year soaring high above and plunging far below the rest of the solar system. For years, Eris was thought to be Pluto's larger twin, but in 2010, astronomers had a chance to measure it with incredible precision. Eris passed directly in front of a distant star, an event known as a stellar occultation. By timing how long the star's light was blocked from different locations on Earth, they could calculate its size with pinpoint accuracy. The result was a surprise. With a diameter of 2,326 kilometers, Eris was almost exactly the same size as Pluto, and in fact, slightly smaller. This revealed the most crucial difference between the two worlds. With a mass 27% greater than Pluto's packed into a slightly smaller volume, Eris must be significantly denser. Scientists calculated its density at 2.43 grams per cubic centimeter, substantially higher than Pluto's 1.85 grams per cubic centimeter. This points to a very different internal structure. While Pluto is thought to be a roughly 70-30% mix of rock and ice, Eris must be composed predominantly of rock, with only a comparatively thin mantle of ice on top, a rocky heart in a frozen shell. That shell is also one of the most brilliant surfaces in the solar system. Eris has an incredibly high albedo of 0.99, meaning it reflects 99% of the sunlight that reaches it. This dazzling brightness is potentially due to a phenomenon called atmospheric collapse. Like Pluto, Eris has an atmosphere, primarily composed of nitrogen and methane ice that is turned to gas. But as its extreme orbit carries it into the deep freeze of its aphelion, this atmosphere freezes solid and falls to the surface as a fresh, bright layer of frost or snow. As Eris begins its 280-year journey back towards the Sun, this frost will warm and sublimate, turning back into a gas and renewing the atmosphere, only to freeze and fall again centuries later. And more recently, observations from the James Webb Space Telescope have added another layer of complexity. Analysis of different isotopes of methane on Eris's surface suggest they may have been produced by geothermal activity, hinting at unexpected thermal processes deep within its rocky core. This distant, frozen world may have, or at least once had, a warm heart. The key to unlocking Eris's secrets, and the final piece of evidence that would seal Pluto's fate, came in September 2005. Using the Advanced Adaptive Optics System on the WM Keck telescope, a telescope that corrects for the blurring effects of Earth's atmosphere to produce space telescope quality images, Mike Brown and his team spotted a faint companion orbiting Eris. It had a moon. This changed everything. While an object's size can be estimated from its brightness, its mass can only be determined with certainty by observing its gravitational pull on another body, for instance, a natural satellite. By carefully tracking the moon's nearly circular 16-day orbit, the team could apply Kepler's law of planetary motion to calculate the mass of Eris with great precision. It was this calculation that definitively proved Eris was more massive than Pluto, making the planet debate not just an academic exercise, but an urgent necessity. The moon itself is a stark contrast to its parent. While only 25% the diameter of Eris, this moon is one of the largest of any dwarf planet, second only to Pluto's own Charon, and larger than Saturn's Enceladus or Mimas. It's also tidally locked to Eris, but estimates of its mass from how much it causes Eris to wobble in its position are far below what would usually allow tidal locking. This suggests that Eris itself dissipates energy far more easily than we first thought. While Eris is brilliant white, its moon is incredibly dark, described as being darker than coal. This suggests a very different surface composition, devoid of the bright frosts that coat Eris. The leading hypothesis for the moon's origin is a giant impact, much like the one that formed Earth's moon. Early in the solar system's history, a massive object likely slammed into the young Eris, blasting a cloud of debris into orbit that eventually coalesced to form a single satellite. This violent birth would have stripped away volatile ices, leaving behind a darker, rockier body. Just as Eris was named for the goddess of discord, her moon was given the name of her mythological daughter, Dysnomia, the demon spirit of lawlessness. The name is fitting for a moon born from chaos, orbiting a world that overturned the established laws of the solar system. In the years since the 2006 vote, Mike Brown has earned the name the Pluto killer. But this misses the true legacy of his discovery. Finding Eris didn't kill Pluto. It revealed Pluto's true family, making our solar system larger, more complex, and more interesting. For decades, we had a flawed model, 8 planets of a certain character, and then one strange outlier. By forcing this reclassification, Eris gave us a more accurate and coherent picture of our cosmic home. There are 4 inner rocky terrestrial planets. There are 4 gas and ice giants. And beyond them lies a vast third realm, a swarm of thousands of icy dwarf planets, a population of worlds whose existence we were only just beginning to grasp. Eris and Pluto are kings of this third zone, the largest and most prominent members of the trans-Neptunian population discovered so far. And Eris itself remains the ultimate mystery. It is the most massive known object in our solar system that has not been yet visited by a spacecraft. While NASA's New Horizons mission gave us a breathtaking, intimate portrait of Pluto, Eris remains a distant point of light, its secrets held across billions of kilometers of empty space. A proposed flyby mission would take an estimated 25 years just to reach its destination, a journey that would span generations. For the foreseeable future, the goddess of discord will keep her secrets. Her discovery resolved one great debate, but it opened up a new chapter in our exploration of the solar system, reminding us that the most exciting discoveries are not those that provide the final answers, but those that reveal just how much more there is left to explore. The Astrum newsletter is one of the most beautiful reads you'll ever get. Even if you're not in it for the news, our photo of the week always makes it worth opening. Sign up with the link below. It's a quick, inspiring way to stay connected to everything happening in the cosmos, from discoveries to missions and the stories behind them. Each issue is carefully designed and written to make science feel exciting and easy to follow. If you already enjoy our videos, you'll love having this in your inbox every week. Join thousands of readers exploring space with Astrum.